All right. So on Friday, we talked about finding arcs, right, and arc measures. And arc measures, we were using what units to measure arcs at that time? Anytime we talked about the measure of an arc on Friday, we measured that using what units? Degrees, right? So if we look here, for example, in our picture, right, we have a circle, okay, and we have an arc AB, okay, described here, and it was 60 degrees, okay? And we also, talked about like other, like different size circles. For example, if I had a circle, forgive my, okay, so let's say I had a circle, within a circle. These are called concentric circles with the same center, concentric, okay? And let's say that the angle measure here was like, I don't know, 30 degrees, we'll say. Okay. If that central angle was 30 degrees, then we knew that this arc right here, from like A to B, would also be 30 degrees. But then we also knew that this arc right here is also 30 degrees, okay? Because both DE, arc DE, and arc AB, okay, are cut out by this central angle DCE, or ACB, right? So this central angle, 30 degrees, cuts out this arc AB, but also this arc DE. It's a little bit weird, though, for us to say that AB and DE both have the same measure, because if you were to like make this in real life and like measure the arc from A to B and measure the arc from D to E, the measure, it's like, well, the lengths would be different, right? I mean, clearly this is shorter than DE is, right? But the measures are the same, okay? So yes, both of these will be 30 degrees, but the key is that their lengths, the actual lengths if you were to measure them, using like a ruler or like a piece of string with a ruler or something like that, they would not be the same, right? They would be different, okay? And that's what we're going to talk about today is arc length, finding the actual distance along a circular arc, okay? So we already know, right, an arc is an unbroken part of a circle consisting of 2 points called the endpoints and all the points on the circle between them. Okay, so A and B are the endpoints of this minor arc, and then it consists of all the points between them too. Arc length is understood to be the distance along a circular arc measured in linear units. So now our units are going to be like in feet or centimeters, right, or inches. Okay, and we can use proportional reasoning to find arc length. Okay, so we're going to find the arc length from A to B here, and we're going to express our answers in terms of pi, rounded to the nearest hundredth. Okay, so the first thing we're supposed to do here is find the circumference of the circle. So we already have the circumference formula, 2 pi r. So we're going to substitute the radius, which is 9, in for r. So we get 2 times pi times 9, which is 18 pi. Okay? Now, for letter B, right, the entire circle has 360 degrees, right? So one way we could talk about going around the entire circle is saying 18 pi, right? 18 pi is one full trip around the circle there. It would take 18 pi centimeters to go around the full outside of the circle, but how many degrees would it take to go around the circle? 360. Right, exactly right. So we're not interested in going the whole way around the circle here. We're interested in going only 60 degrees. What part of the whole circle is 60 degrees? 1/6, right? Or 60 3/60ths, which is 1/6 of the circle, or in other words, for the distance, it's the 1/6 of the circumference. Okay? So 60 degrees is 1/6 of the circle. So 1/6 of the circumference should then give us the arc length. So we'll do 1/6 times 18 pi. What's 1/6 times 18 going to be? What's 1/6 of 18? Avery? 3, right? 18 divided by 6 is 3, so it's 3 pi. which is approximately 9.4, and of course 9.4 centimeters. Okay, so the arc length of arc AB is 3 pi centimeters, or 9.4 centimeters. So if we were trying to find the length of an arc that was 60 degrees, what did we do? We did the circumference times 60 over 360. So if I were trying to be more general here, if I want to find the arc length for an arc measured m degrees, so not 60 anymore, but if I wanted to find the arc length of a arc that was m degrees, what would we do with that m? M over what? So let's say this is not 60 anymore. Let's just say it's m, some measure m. What should we do with that m? M over what? M over 360 times, what did we multiply that fraction by? Right, we did 60 over 360, or 1/6. We did 1/6 times 18 pi. What was 18 pi? The what of the circle? Circumference. So it's m over 360 times 2 times pi times the radius. And that's your general formula there for the arc length. It's just the circumference times the fraction of the circle that you want. Okay? Fraction of the circle times the circumference there. That's it. Okay? Questions on any of that? All righty. So there, if you turn the page, you can see it. Okay? Arc length S of an arc with measure m degrees and radius r is given by the formula S equals m over 360 times 2 pi r. So lowercase s is used for arc length. Okay? Why isn't it like a lowercase a, or why isn't it like al? Beats me. But s is the typical variable used to describe arc length. Okay? I guess a doesn't make sense because we get a confused with what other idea? Probably area, right? So we don't use a. But s is what we use for arc length. All right? So here's an example of a problem, right? Okay, so on a clock face, the minute hand of a clock is 10 inches long. To the nearest tenth of an inch, how far does the tip of the minute hand travel as the time progresses from 12 to 12:15? Okay, so from 12 to 12:15, the hand moves 15 minutes. The minute hand moves 15 minutes, right? 15 out of a total of 60 minutes on the clock face. So 15 out of 60, that's 1/4 of the clock, which is then 90 degrees. Okay, right? From 12 to 12:15, that's 1/4 of the circle, so 90 degrees. Okay? And so then 90 over 360 times 2 times pi times the radius is 10, because remember the minute hand is 10 inches long. And so how far does that tip of the minute hand travel? 5 pi, or 15.7 inches. That's the distance around there. So let's try this one here. The minute hand of a clock is 6 inches long. To the nearest tenth of an inch, how far does the tip of the minute hand travel as the time progresses from 12 to 12:30? Okay, so from 12 to 12:30, what degree measure is that? Minute hand starts at 12. Whoops. Minute hand starts at 12 and turns down to 12:30. What degree measure is that? 180, right? Half the circle. Okay? So it'd be 180 degrees. I'm skipping some of the steps that they did. Times 2 times pi times, what's the radius of this circle going to be? 6, because the minute hand of a clock is 6 inches long. So it's 1/2 times 2, which is just going to be 1, times pi times 6, so it's 6 pi, or approximately 18.8 inches. Okay, so the length of the arc is about 18.8 inches. Okay? Questions on any of that? All right, so why don't you all try Number 3. Okay, try number 3 there on your own. Minute hand of the clock is 8 inches long to the nearest tenth of an inch. How far does the tip of the minute hand travel as the time progresses from 12 o'clock to 12:45? Okay, 12 o'clock to 12:45. Let's give that a try. Yeah, go ahead. So give that a try. I'll come around and help you here. By the end of the day. By the end of the day. All right, let's take a look here. All right, number 3. Well, the only problem I guess you had to do. Let's go to Steven. Steven, you come up with an answer here for this.
I wasn't done.
Oh, okay.
Yeah.
Sorry. Did you have a setup for us at least?
Yeah, I did 3/4.
Okay.
Times 360, and then I had that equal to 270.
Okay, so I see what you're saying. So 270 degrees over 360, which is the same thing as 3/4 there.
Yeah.
Okay, so then we're going to do 3/4 of the circumference. So 3/4 times 2 times pi times the radius. What's the radius of our circle going to be here?
I wasn't sure.
Well, the minute hand is what we're measuring here. The minute hand of the clock is 8 inches long.
Oh, okay.
So it's going to be 8. Okay. So 2 times 8 is 16. Over 4 is going to be 4 times 3 is 12, so it's 12 pi is what you should have gotten there for your precise value, okay? But then approximately then, that is 37.7, okay? Inches. Questions on any of that? Okay, so the next thing we're going to look at is a different unit of measure than degrees to measure angles. So I know we kind of are jumping around here. We started with talking, like Friday we started talking about the measure of an arc, right, or the measure of an angle, right? We use degrees for that, right? But then today we just jumped into arc length, which is now in like inches, centimeters, feet kind of thing. It's the actual like distance an arc, kind of takes to travel an arc, all right? And then we're jumping back now to measuring arcs and angles using something called radians, a different unit of measure, okay? And these radians are something you're going to see, again, definitely in pre-calculus and calculus, should you, go on to those classes. And I think in Algebra 2 as well, but I'm not so sure about that, okay? So I'm going to introduce this to you, though, in a slightly different way than they do, because I think that this way is a little more simple than what the point they're trying to get across here. Okay, so we'll do that. Let's see, do I have space here to kind of do it? Yeah, I think I'll have space here. So we'll just kind of skip down here and just do it kind of in this space. So we're not really doing B, but we're going to use this little space right here to kind of talk about what a radian is. Okay, so we have two different ways to measure around the outside of a circle, right? One way is using degrees, right? And how many degrees go on the outside of a circle? 360 degrees, right? But alternative to that, we can also measure on the outside of a circle using a circumference. And what's the measure, what's the formula for a circumference again? Two pi r, or pi times d, but we're going to use 2 pi r for this one. 2 times pi times the radius. Okay? Which means then, if I kind of set these two ideas equal to each other, right? Because 360, it's going around the outside of the circle once. 2 pi r goes around the outside of the circle once. If we use those two ideas together here, we can see then, okay, if I divide both sides by 2 here, I get 180 degrees equals pi times the radius, right? Just divide both sides by 2. And then I can also say, if I divide the pi over, I have that r equals 180 over pi. Okay? And that is where we get the idea of 1 radian is equal to 180 over pi. Okay? It's a different unit of measure. A different unit of measure there to measure the outside of a circle. Okay? So it is equal to, so approximately, let's see here. 1 radian is equal to 180 divided by pi. So it's approximately 57.3 degrees, because you have to round that, because again, pi. So the 1 radian is approximately 57.3 degrees. Okay? Just like, we have conversions for inches to centimeters, or from, feet to miles and stuff like that. This is our conversion for radians to degrees. 1 radian is 57.3 degrees, but of course we use 1 radian is 180 over pi. Okay, so if we turn the page here, and let's say we want to convert 180 degrees into radians. Okay, so we want to convert that 180 degrees into radians. Okay, so we use 180 degrees. Okay, and we're going to put that over x radians. We don't know. I'm going to abbreviate with RAD there. Okay. We're going to make like a proportion here. 180 degrees is proportional to some number of radians. Okay. And what's the conversion that we know? Well, we know that 180 degrees is pi radians, right? We just talked about that over here. 360 is 2 pi radians, and 180 is pi radians. And so this one's kind of straightforward because it is just what it is there. If we cross multiply and solve here, we have 180 times pi equals 180 times x. Divide both sides by 180, you get x is pi. So x is pi radians. Okay, x is pi radians. Let's try 60, because that one's a little bit more interesting. Okay, we already established that 180 is pi radians, so we'll do 60 degrees. Okay, so 60 degrees, again, we'll start with what we know. We know that 180 degrees, oh, sorry, not 60, we're starting with 60 degrees here. We want 60 degrees, and we want to convert that into x radians, some number of radians there. 60 degrees is some number of radians. And we'll use our conversion again. 180 degrees is pi radians. We know that for a fact. And so we'll just cross multiply here. 60 times pi, 60 pi. 180 times x, 180x. Okay. And so then, to simplify this, to finish solving for x, what do we do to both sides? Yeah, divide both sides by 180, right? So we get x equals 60 pi over 180. But of course, we can simplify that, right? So you should simplify it. 60 and 180, well, we can both divide those by 10, so it's 6/18. But what does 6/18 simplify to be? 1/3. And so you can say x is 1/3 pi, or if you want to, you can say pi over 3. Okay. So 60 degrees is pi over 3, or 1/3 pi. Okay? I think there's some more here. Yeah, here's some more for us to try on the next page here. Okay? So 90 and 45, go ahead, convert those angles into radian measures. Okay? So go ahead and try 7 and 8. Convert those into radian measures. Again, set up a proportion. 100, or sorry, I'm not going to, I don't want to. Remember that you start with 180 degrees over pi is our known kind of ratio there. Okay, 180 degrees over pi radians. Oops, sorry, there we go. 180 degrees over pi radians. That's our known measurement there. Yes. Question. 90 over what? Over x, because we don't know. So don't try and follow what the book's doing here. Like, I would suggest you do it. So you see, we took like the 60 degree. We made it 60 over x equals then 180 over pi. You can do it that way, but I would suggest you. I think this is easier. This is a proportion that you just multiply and solve. So. Okay, just a proportion. Yep. All right. Anyone still need more time on these questions? Anyone still working? All right. Let's take a look at them then real quick. Okay. All right, let's go to Luke. Luke, were you able to come up with the radian measure that's equal to 90 degrees? 90 degrees is how many radians?
Well, I got to the part where it's like 90 times pi equals 9 times x.
Okay, sorry. So what was your initial setup? How about we do that? So 90 degrees over what?
X radius
Okay, x radians.
equals 90 over pi.
So not 90 over pi, 180 over pi. Because we know that, again, if you remember, 360 was equal to 2 pi radiuses, or 2 pi radians, and so 180, dividing those both by 2, equals pi radians. Okay? So you just use that conversion factor. So now we multiply. We get 90 pi equals 180 times x. Divide both sides by 180, we get 90 pi over 180. And how do 90 and 180 simplify? It simplifies to what? Anybody? 1/2. So pi over 2, or 1/2 pi. Okay, just like that. All right, what about 45 degrees? Let's go to Preston. Preston, what'd you get for the radian measure of 45 degrees?
I got
Pi over 4. Great job. Exactly right. Okay, would anyone like to see that one done? 1/4 pi or pi over 4? Emmanuel, you want to see it done? Okay. So, Emmanuel, were you able to set it up, or did you try setting it up? So we want to set up 45 degrees over x radians, right? We want to convert it from 45 degrees to some number of radians. Oh. Sorry about that. Fix that real quick here. So far so good. That's the ratio. 45 degrees is some number of radians. And we want to set that equal to another ratio of known radian degree relationship. So we know that, for example, 180 degrees is pi radians. Okay, so you get that. That's our proportion there. It's a similar relationship. So you cross multiply. So you get 45 pi equals 180x. Divide both sides by 180. So you get 445 pi over 180, which implies to, hello, Jenny. Oh, what a time to show up. Pi over 4. Okay? So pi over 4 is our answer there. Okay? Questions on any of that? Okay. Very good. So, if you would then, let's get started on our assignment. Okay, that's what we'll do. We'll get started. You get started here on your assignment. Okay. So it's going to be page 868. Numbers. One, 5 through 8. Ten. And 13 to 16. 18, 9. Ooh, I also like 22. Yep, 22 as well. Okay, there we go. That's where I'll stop. Okay. Borrow what? There you go, sir. Yep. You're welcome. Oh, thank you for getting that, Marty. I appreciate it. You just put it right up there. That's okay. You just put them right there. I'll fix them. I appreciate it. Yes.